to graph. Yes, you're correct. A vertical asymptote at 1 and the horizontal asymptote at 1. And now I have to graph this at -3. 1, 2, 3. 5.4 is somewhere here. And I didn't have to fill it in. I specifically not wanted to fill it in, but I did. Now I'm going to make it huge. Okay, ready? From approaching 1, going through this point, crossing at 0, 2, and going to infinity. This all happened only because that factor of x plus 3 went away from the top and went away from the bottom. And on the other side, so this is 2, from negative infinity, crossing it to 0 and approaching 1. So this is the function x squared plus x minus 6 over x plus 3, x minus 1. I wanted one factor to go away. So with the graphing calculator, please put in the top and the bottom in parentheses the original function. Okay, so in parentheses, we have x squared plus x minus 6. And divide by, make sure you have to have 2 sets of parentheses. So x plus 3, close, multiplied by x minus 1. Close this and close one more. Which other function do I have to put in because the calculator will not put it in? Which is? Not vertical, because this is all y equals. So I cannot put, I'm not saying you would have said that, but I'm just saying I cannot put x equals. So what else I have to put in? 1 indeed. Ready? So I'm going to use the standard for now, zoom 6. Let's see what happens. Here it comes. Here it comes. And now the horizontal asymptote. I know it's lying. The function does not overlap with the horizontal asymptote. I know the function doesn't overlap with the horizontal asymptote, but I want to zoom in and see that what happens at -3. So I go to the window and I want to go to a look at between -4 and -2, and with a scale of 1. And y minimum, I'm going to say -1, and y maximum, I'm going to say 3. Here it is. At -3, a hole in the graph. There is no vertical asymptote. If there were a vertical asymptote, the function would have done this. It doesn't. Open point. Only because this factor went away. This factor. The function is still undefined. That's why it will be a hole in the graph at that point. Any questions? Any questions? Okay, let's look at the last function. And on Thursday, I would like to show you applications of this function. Very useful function. And finish up with 3.6, which is inequalities, polynomial and rational inequalities. Okay, here's type 3. Yes. Is this type 3? Yeah. Why? At the top is exactly 1 degree more than the degree of the bottom. What's the key here? What's the idea? What really happens here is this. This function will not have a horizontal asymptote. This is the only one that does not have a horizontal asymptote. Type 1 and type 2 have horizontal asymptotes. This one will have, instead of a horizontal asymptote, a slant asymptote. Either this way, and that will give us the behavior, and behavior what? From negative infinity to positive infinity. Or it can have this slant asymptote, which will give us, like, the function has to follow the horizontal asymptote. In the same way, it has to follow the slant asymptote. So if the slant asymptote looks like this, then the end behavior for the function will be from positive infinity to, yes, depending on the slant asymptote. Everything else is the same. So what do you think I'm going to do first, before I get my chart going? Yes, of course. Thank you. Good. So what will you say about the top? Very good. Good. So I'm expecting the domain now, please. Very good. Does this factor of x minus 2 go away with the factor from the top? Because if it does, it's a hole in the graph. If it doesn't, what will I conclude? What do I write if it doesn't go away? It's a VA. Very good. Once you say VA, you will give me infinities left and right. And let's use something close. 1.9, 2.1. So please plug in 1.9 in the first quantity. Sign. Good. 1.9 in the second one. And 1.9 in the bottom. Perfect. So what is the sign on the left-hand side of this asymptote? Awesome. Let's plug in 2.1. 2.1 for the first. 2.1 for the second. And 2.1 for the bottom. Good. All positives. What is the sign on this side? That's it. Please plug in 0. And tell me what you get. Please tell me, when is this function 0? You saw it took us 15 minutes the first problem. It took us less and less. It takes us less and less. Okay. So when is the function 0? For x equals, it cannot be 0 for x equals 2. It's undefined for x equals 2. Right? Is that okay? So this function is 0 for, I know it's late, but it's a ratio. It's only when the top is 0. That's why we factored it, so identify the x-intercepts right away. So when is this 0? Or, that's it. -3, 0, -1, 0. Finally, we have to talk about the end behavior. This is the last thing we need to do. Ready? Okay. We have to divide, either using synthetic division or using long division. One more time. What is the degree of the top? What is the degree of the bottom? When I divide, what will the degree of the quotient be? 1, right? If I divide degree 2 by degree 1, I cannot get degree 2, correct? Okay. I get degree 1. Okay. Whenever I think of degree 1, what function am I thinking of? What function has degree 1?
Linear.
Linear. That's why it's the slant asymptote. The quotient will be the slant asymptote. That's why it's required the degree of the top to be exactly 1 unit higher than the degree of the bottom, so that I can get that line. That is the slant asymptote. So, you want to use synthetic division or long division? Okay, long division then. X squared plus 4x plus 3, x minus 2. First step, x times what is x squared? Perfect. X times x. I have to lie and change the sign. X times negative 2. I have to lie and change the sign. Perform the operations I see. Final question. X times what is 6x? Sign, I need a sign.
Plus 6.
Very good. So 6 times x is 6x. I subtract. And 6 times negative 2 is negative 12. Good. So I box in 15, which I don't care about. What is the quotient? Yes. Yes. So this is the quotient and this is the slant asymptote. The remainder does not do anything because the remainder will be over x minus 2, and at the infinities that will be 0. So this is the slant asymptote. I'm going to write it here. Y equals x plus 6 SA. On both sides, of course. So now the question is, what type of line is x plus 6? Is it this? Or is it this? Number 1 or number 2? Number 1. So then I know the end behavior of the function. It has to follow the slant asymptote from negative infinity to positive infinity. Okay, I'm going to try and make sense of this information. This doesn't make any sense here, obviously. Something is going on there. So let's give it a shot. From negative infinity, so the slant asymptote is this. So the function starts close to the asymptote at negative infinity. Let's see what it does. It goes up and crosses at negative 3, 0. It has to turn. It's a must. It has to turn because it comes back and crosses at negative 1, 0. It crosses the y-axis at 0, negative 3 halves, and goes towards negative infinity on the left-hand side of the asymptote. So it has to look something like this. Here approaching the slant asymptote, and here approaching the slant. Here approaching the slant asymptote, and here approaching the vertical asymptote. One more time. From negative infinity, it crosses the x-axis at negative 3, 0. It has to turn because it crosses again at negative 1, 0. Now it crosses the y-axis and going towards negative infinity. So there must be a maximum here. Let's see the other side. This makes no sense. From infinity to infinity, how is that possible? This is how it's possible. With a minimum. So from positive infinity approaching the vertical asymptote, going to positive infinity approaching the slant asymptote. So let's graph it. What do we graph first when we graph functions with asymptotes? Yes. How many asymptotes we have to graph here?
1.
One more time.
2 and 5.
2. One is the vertical asymptote. And the other one is the slant asymptote y equals x plus 6. I need to find the x and y intercepts. When x is 0, how much is y? Good. When y is 0, how much is x? Very good. Here's the slant. Ready? Okay, here's my chart. I have to plot -3, 0, 1, 2, 3, -1, 0, and 0, -3/2. So from approaching the slant asymptote, crossing at -3, 0, coming to a maximum, crossing again at -1, 0, crossing at 0, -3/2, and approaching the vertical asymptote towards -infinity. On the other side, from positive infinity, going to positive infinity. With the graphing calculator, how many functions do I have to put in? The function itself, x squared plus 4x plus 3 over x minus 2, and what else? Which one?
X plus 6.
X plus 6. Very good. So, in y equals, clear everything. For the second one is x plus 6. And then the first one, in parentheses, x squared plus 4x plus 3. Close the parenthesis, divided by x minus 2. Now, in this particular case, I will have to find that minimum, the maximum between -1 and -3 and -1, and the minimum. I don't know how high, how low. I doubt that the standard viewing window will work. So I'm going to go to the window and say, the left-hand side, -10 is fine. The right-hand side, I shouldn't go that far, but I don't know how about the top. So I'm going to say 10, the scale of 1. Y minimum, I don't need to go too far down, -5, but the positive one should be probably 20. I don't know. Let's say with a scale of 5. Here it comes. And the slant. So from approaching the slant asymptote, crossing a -3, 0, reaching a maximum, crossing again at -1, 0, crossing at 0, -3/2, and going towards -infinity. And the top is that kind of a parabola, which is not. So in order to find the maximum here between -3 and -1, I will go with second and table, second and calc. So I want the maximum, which is 4. It's between -3, enter, and -1, enter. And I want the maximum, and I'll put it in as -1.87, -1.87, and the maximum is very tiny, 0.25. Now I'm interested in this minimum here, and I know I put positive 20, so with a scale of 5, 5, 10, 15. So between 15, no, what is this? It's a scale of, what did I use as a scale?
That was still 1, I think.
Scale 5. So with second and calc, I want to determine the minimum. That's number 3. And it will ask me why is it giving me, I chose a scale of 5. Anyway.
Your X scale is only 1. Your Y scale is 5.
Oh, the X scale is 1. Yes, thank you. Thank you. Okay, thank you. So that's somewhere between what? 4. So I'll say 4 as the left bound. And I don't have to calculate anything. I can just scroll it to the right. I'm fine there. Okay, so the minimum is at 5.87, and the minimum is 15.75. And I put them in the chart. So the minimum, this is 5.87, 15.75, and the other one is tiny, is right here, is at -1.87, 0.25. Any questions for me?